Welcome everybody in AP Chemistry series. Today we complete section 7.9 part 2, which is all about introductions to Le Châtelier principle. In the previous class or previous video, we covered the factors in which the Le Châtelier principle depend on, in which they are concentration and pressure. Today we will cover the temperature. Since we're talking about temperature, thermochemistry, you're supposed to know the types of reactions in which they are endothermic and exothermic. So what will happen to the direction of reaction if we have endo or exo as a result of changing the temperature? So let's start with endothermic. I just want to give you an example of samples, like if we have reaction of A plus B, they are in equilibrium with product C. And I just tell you that the delta H is equal to positive, let's say 30 kilojoule per mole. You have to determine the type of reaction based on the sign of delta H. And since the sign of delta H is positive, it tells me that this reaction is endothermic. Or you can represent that in terms of delta H just greater than 0, which means it's a positive value. So it could be represented either with a real positive value, like positive 30 kilojoule per mole, or any number, or delta H greater than 0. So both work. In some questions, those guys in here could not be denoted. For example, instead, they can tell you that the reaction has heat as a reactant. So at that point, you have to say, okay, since the heat is in the reactant side, okay, this is the reactant, then the reaction for sure is endothermic. A plus B gets C, the delta H is greater than 0. So since the delta H is greater than 0, I have to say, okay, then it means that we have heat right here on the reactant side. What will happen to the direction as a result of increasing the temperature? What will happen? So first of all, we're going to deal the same thing. We're going to deal with heat as a reactant. So as we increase the temperature, then I have to increase it like this. And if I increase it, the reaction will be shifted to form more products and consume more reactant. Another way, just remember this seesaw thing. We have a beautiful seesaw in here. We have reactants and products. If we increase this level here just a little bit, it becomes like this way. And that's why the balls here will start to slide down. So the reaction will be shifted to the product at the point. Now, just like, let's remind you, since the reaction is shifting to form more products, okay, then what will happen to the value of K or Kc or Kp? Since the Kc or Kp is a ratio of the products over reactants, and we have increasing in the product, then the K value will increase. All right. By the way, shifting to the product, it means also decreasing in the reactant. So at that point, I have to say that the temperature is the only factor, this guy in here, temperature is the only factor that leads to change the value of K or the equilibrium constant. So increasing the heat leads to shift the reaction to the products. It means more products, less reactants, the K is higher. Now let's take it in other way. What will happen if we have the same reaction but I'm decreasing the temperature? A plus B gives C, and delta H is greater than 0. So at that point, I have to say, since it's greater than 0, it means it's positive, it means it means the heat is in the reactant side. Then I have to say, the second case says, what will happen if we decrease the temperature? What will happen? So I'm decreasing the temperature, which means that we have loss. And just remember from the previous video, the direction of reaction tends to be in the loss direction because they want to compensate the loss in here. So all of these guys in here from products will be shifted to the reactant. Reaction will shift to reactant side. All right, sensate more reactants, that's what will happen to the value of K. K actually represents the ratio of the products to the reactant. And since the reaction is shifting to form more reactants, then the reactant concentration will increase. And since the denominator here is increasing, what will happen to the value of K? It will decrease. The value of K will decrease if we lowering the temperature for endothermic reaction. Let's talk about exothermic reactions. How can I deal with them? What will happen if we have increasing or decreasing in the temperature? So we're still in the same example, but in exothermic form. So if we have A plus B gives C, and delta H is equal to negative, let's say, negative 30 kilojoule per mole. It's not the number, but it's all about the sign of the delta H. As the sign is negative, then it tells me this reaction is exothermic reaction. The delta H in terms of less than zero. So if delta H is less than zero, then the reaction is also an exothermic. I can represent the exothermic reactions another way, which is just adding the heat and the product side. So the exothermic heat is in the product, heat is in the product, and for endothermic, the heat is an reactants. I have to start with the first case in which we are increasing the temperature. What will happen? I'm increasing the temperature to the side of heat because, like temperature and heat are related to each other. And that's why the reaction will be overwhelmed of the product side, and that's why in order to decrease the stress it will shift to form more reactants and decrease the product. So the reaction will shift to form more reactants and consume more products. All right, what will happen to the value of K since the K value depends on the temperature and we are changing the temperature? As we just noticed, since the reaction is shifting to form more reactants, since the K is equal to products to reactants and reactant here is increasing, okay, so what will happen to the value of K? For sure it will decrease. So in exothermic, if you increase the heat, the K value will decrease. Let's jump to the next case. What will happen if I decrease the temperature for an exothermic reaction? A plus B, here we have C plus heat, and delta H is less than zero. So I will take the second case in which we are decreasing the temperature. Okay, if we are decreasing the temperature, then it means that we have loss. And since you have loss, the other guys in the reactant will compensate this loss by shifting to form more products at that point. So at that point here, the reaction will be shifting to the product side and more products will be formed. As a result of that K value, which is products over reactants, we have increasing in the products and decreasing in reactants. That's why the value of K will increase. So what we have to learn today, if you have A plus B, any chemical reaction that is in equilibrium, and if I tell you that the delta H is, for example, let's say it's greater than zero, then it tells me that the forward reaction is endothermic and the backward reaction is exothermic. The forward is endo and the backward is exo. If the delta H is less than zero, then the forward will be exo and the backward or the reverse reaction will be endothermic. Okay, so don't confuse these things. Now let's take this beautiful example. As we can see, we have a beautiful reaction that gives you different colors based on changing the temperature or even changing the species. So since the value here, delta H, is greater than zero, and it tells me that this reaction for sure is an endothermic reaction. If it's endothermic reaction, then I have to insert the heat and the reactant side. Here we have heat right here. What will happen if I increase the temperature? As we said, increasing the temperature leads to shift the reaction to the other side because we have so many things on the reactant side. All of these will be shifting to the product side. And that's why it will change from pink to blue at higher temperature. And you can see from here, it turns to blue. On the other hand, if I decrease the temperature, which means that I have loss, the reaction wants to shift to compensate this loss. And as a result of that, if it's blue, then it will be changed to pink color. And as a result, you can see here, it will start to be pink, in which we are decreasing the temperature for an endothermic reaction. Pause the video and read this question carefully. The question is endothermic because it's a positive delta H. Since it's positive, then it tells me that the heat must be in the reactant side. All right. So what's the question? It says which procedure will cause this equilibrium to shift to the left. Where's the left? By the way, don't use left and right in AP exams. They're not acceptable. Just like say it leads shifts to products or reactants. I just said. Now I need to be shifted to the reactant side. How can I do this process? Let's see the first choice, and it says a decrease in temperature. Okay, if I say decrease in temperature, then I have loss. Then the reaction will be shifting to compensate this loss, right? That's why the answer for sure is A. Let's see B. It says an increase in the temperature. If I increase the temperature, the reaction will be shifting to the product side, and that's why it won't be shifted to the left side. A decrease in the volume of the system. Okay, decreasing the volume means increasing the pressure. If we increase the pressure, it will shift to less number of gas moles. How many gas moles we have? We have two. Okay, just want to erase the stuff, the whole thing. Okay. How many gas molecules we have here? We have two. How many gas molecules we have? Two. As long as you have the same number of gaseous molecules on both sides of the equation, then the pressure is no longer an effective factor. It doesn't affect on equal number of gases. So that's why C is wrong. A is true and B is wrong. An increase in the volume of the system. Now, as we said, both guys in here affecting the pressure, and the pressure has no effect as we have the same number of gaseous species. That's why the answer is A. Pause the video and read this question carefully. Quicklime CaO is produced from a limestone CaCO3 according to the equilibrium reaction. Since the heat actually is in the reactant side, this is an endothermic reaction. Okay. Which of the following procedures result in producing maximum quantity of a quicklime? What's the quicklime? I forgot it. Yeah, this is the CaO. So this is my reaction. I need my reaction to be shifting to the product side. So which of these procedures down below leads to shift reactions to the product side? Let's start with the first one. It says lower the temperature and allow CO2 to escape. Okay, if I decrease the temperature, I want to erase the stuff. I want to raise everything. Okay. If I decrease the temperature, it means that I have loss. And since you have loss, they will come to compensate. So what will happen to the value of CaO? It will decrease. A is incorrect. B says raise the temperature and allow CO2 to escape. Okay, we have temperature. If I increase the temperature, the reaction will be shifted to the products. CaO will increase. And it says allow CO2 to escape. It means that I'm losing CO2, which means that it also will be shifting to the product side. And that's why answer B is correct. All right, all right. C says lower the temperature. No, lowering the temperature doesn't work. But D, why D is wrong? Since the question is asking me, I need my reaction to be shifting to the product side. And it says raising the temperature. This is true for the first part, but the second, it says finally grant CaCO3. And actually this one here, if you have small particles, it affects on the rate of reaction. And since you have an equilibrium, it will be in both directions. So it will increase the rate of reactions in both directions. So it won't affect. That's why B is correct. Okay, since the delta H is given to me, it's negative, then it's an exothermic. I have to say plus heat. Okay, the question says, which procedures causes an increase in the value of K? It means I'm needed to be shifted to the products because, K is equal to products of reactants. Since more products, it means it has to be shifted to the product side. So since the reaction is exothermic, heat is in the product side, what should I do? Decrease the volume? Just remember, the only thing that affect on the value of K is temperature. So it's not volume, it's not concentration, it's not pressure. Increase the temperature. If I increase the temperature on the side of heat, the reaction will be shifting to the reactant side and more reactants will be produced, and that's why it's not. And decrease the temperature. Yes, if we decrease the temperature, it means here we have loss, right? The loss needs to be compensated by reactants, and that's why the reaction will be shifting to the product side, and that's why we have higher value as the product amounts will increase with respect to the amounts of reactants that will be decreasing. So the answer here is C, and D actually affects only on the rate of reaction. Here it's a beautiful and tricky question. Pause the video and read the question carefully. You can notice that the value of K's are increased as a result of increasing the temperature. What is the type of endo or exothermic that if we increase the temperature leads to produce more products? So for sure it's an endo, because if you have heat, if you remember, plus A, for example, and here we have C plus D whatsoever. If we're increasing the heat, the reaction will be shifting to the product side, which means more products at that point. So the K value is equal to products of reactants, more products, more K. And since you're increasing the temperature, this is the only possible answer. Okay, the reaction will shift left. No, it will be shifting to the right, which is a product. Don't say right or left. The equilibrium shifts left. No, it's not right. C says equilibrium shifts right, and the reaction is exothermic. No, it's not exothermic. The heat is in the reactant side. So D says equilibrium shifts right, and the reaction is endothermic, and D is the true one.